Hi YouTube, this is Antonio. So today we are going to go over the Edexcel triple science chemistry knowledge. Alright, so for the first section we're going to talk about the Avogadro's constant, 6.02 times 10 to the power of 23. And how could a question come up? For example, let's say they ask you, how many atoms of oxygen is there if in 1 mole of oxygen? So it's like this. When you have 1 mole of oxygen molecules, in each molecule there's 2 oxygen atoms. So the answer to that question would be 2 times 6.02 times 10 to the power of 23 atoms of oxygen inside 1 mole of oxygen molecule. Alright, does that make sense? And you have to be able to apply to ions, electrons, molecules, etc. Alright? So moving on, for the next point is actually a double science point. You have to be able to calculate moles using mass over relative atomic mass or relative formula mass equals to moles. And that's all you need. Okay, remember when you're doing any equations or questions related to moles, if a chemical equation is involved, you have to use the mole ratio, which is the coefficient in front of the reactants and products. Alright, so that's, you have to go back to your double knowledge and revise before going into that. Now, the next bit is also about the abundance. Alright, so basically, let's say for example, chlorine 35 is roughly 75%, and chlorine 37 is around 25%. Okay, you do this equation right there, and you add up. You multiply and then add up to get 3,550, and then you divide it by 100, okay, to get the relative atomic mass, which is the average of its isotopes relative to 1/12 of carbon 12. Okay, the next bit is not difficult. Alright, you have to know that 1 mole of any gas will occupy 24 dm cube, or we can say 24,000 cm cube under room temperature and pressure, and do the good calculations of that. Alright, so remember gas calculations, you can easily convert any moles, multiply by 24, and you get the volume it occupies under room temperature and pressure. Alright, and that's what you have to know. Now, for the percentage yield, okay, we're looking at experimental yield divided by the theoretical yield times 100%, and that's the percentage yield of a chemical reaction. So working out whether or not the chemical reaction is efficient or not. Alright, if let's say the experimental yield is like 99.8%, that's really super high. But in most cases, it's actually quite low, because there may have been some unreactive reactants. Maybe there was some loss of products or reactants during the process, or the reaction just did not complete itself. Alright, now moving on. Again, not too difficult. You have to remember that the melting point and boiling point, which we're talking about, the physical properties, are related to the ionic charge. Okay, higher or greater ionic charge of ions, greater the melting point and the boiling point. So I gave an example in which magnesium oxide is stronger, okay, or higher or stronger physical properties than sodium chloride, because magnesium is in group 2, oxygen is in group 6, so +2 ion and -2 ion, alright, versus +1 sodium ion and -1 chloride ion. Okay, so basically this is what you see right here. Okay, and this is the formation of an ionic bond, and basically a transfer of electrons, and then the attraction between oppositely charged ions. Okay, moving on. Alright, you have to know that an ionic crystal, you can see here, let's say sodium chloride. Okay, imagine the purples would be the sodium, and then the chlorine would be the green ones, right? So they are all oppositely charged, and there's a strong force, and they hold each other together. Alright, and if you are asked to draw it out, this could be the graphical representation of it. Okay, moving on. You also have to know how to draw diagrams which shows the arrangement of the atoms in diamond and graphite. Alright, so here's a diamond, okay? Inside is carbon, and carbon is in group 4, so it can form 4 covalent bonds right there. Okay, so each carbon should be able to do that, and it forms a really strong bond. And if you have to melt it, you have to break all the covalent bonds, and that requires a lot of energy. Then, this is the graphite one, alright? Now for graphite, it's quite funny. It is a giant covalent compound. However, the strong bonds are within the layers, and in between the layers are weak attractions, which you will have the localized electrons going through the structure. Okay, and for each carbon, we'll have 3 covalent bonds branching out to form hexagons. Okay, and that's graphite. Now, so diamond is actually quite strong. So basically, you can have this diamond burrs, which we use in a dental setting for cutting stuff. All right, and this is graphite being a lubricant. Great. So now the next bit is a bit difficult. All right, you have to be able to describe experiments to investigate electrolysis. All right, you have inert electrodes, okay, reactive electrodes, and here are listed the ones they want you to recall. Okay, for sodium chloride, cathode releases hydrogen. Okay, at the anode there will be chlorine released, and what's remaining in the solution would be sodium hydroxide right there. Now, if you took copper sulfate, okay, and you do perform electrolysis, at the cathode you will have copper, at the anode you have oxygen, and anything remaining inside, alright, would be sulfuric acid, because initially you have the sulfate, okay, and then the sulfate, when paired with hydrogen ions, it will become sulfuric acid. So that's the rationale. Now, but if you take dilute sulfuric acid, electrolysis, you get hydrogen gas produced at the cathode and oxygen gas at the cathode, oxygen gas at the anode. All right, and you end up with more concentrated sulfuric acid. Okay, and here are the half equations. Okay, so remember you have to know oxidation and reduction. And let's say here you have the hydrogen is gaining electrons, so that's reduction. And then you have chloride ions losing electrons to form chlorine. Okay, then that is oxidation. Now students will always ask, why do you have like 2 moles? Why not 1 mole of H plus and 1 mole of Cl minus? It's because both hydrogen and chlorine, they are diatomic gases. Therefore, they need 2 individual atoms, okay, to form covalent bonds to form H2 and Cl2. So look carefully at the aqueous copper sulfate. Okay, this is what happens. Copper gains electrons to form copper solid. Okay, now the hydroxide ions come from the dissociation of water molecules. All right, and then it forms H2O, oxygen, and 4 electrons. Okay, so oxidation right there. For sulfuric acid, hydrogen ions becomes hydrogen gas, hydroxide ions becomes water. Okay, and we have a simple diagram. Okay, credits to BBC. Alright, so the cathode, remember, is always negatively charged. How do we know that? Because cathode attract cations, and cations are positive. Alright, so it's going to go towards the cathode. And then for the anode, alright, is negatively charged. Alright, so it attracts anions. Oh, sorry, anode is positively charged and attracts the negatively charged anions. Alright, and an electrolyte is something which can conduct. Alright, it could be molten state of a compound. It could be aqueous state, which is a solid dissolved in a solvent. Okay, so we went through the half equations already during electrolysis. All right, now the next bit is that you have to know that 1 Faraday represents 1 mole of electrons. Okay, so basically if you go to the example down below, okay, and here we took aqueous sodium chloride as our example. For every 1 mole of hydrogen, you need 2 moles of electrons. Alright, so hence you need 2 Faradays, okay, in order to reduce 2 moles of hydrogen ions into 1 molecule, 1 mole of hydrogen molecules. Okay, and that's the idea. Now, that was it for the session 1. Now look for the next video to look at the knowledge on session 2, which is not too long, because I'm going to break it into small parts so it's easier for you to look at. Alright, so thank you for watching.